What if the very foundations of modern physics are in a, quote, deep crisis, and the unknown secrets of electromagnetism could reveal the path to free energy?
Welcome to the Deep Dive. Today we're venturing into some really fascinating, maybe even mind-bending territory in physics.
Absolutely. We're looking at ideas that sit well outside the usual textbooks, ideas that challenge some core assumptions about electromagnetism itself.
And we're doing this through the lens of one specific, quite provocative source, the book Unknown Secrets of Electromagnetism and Free Energy by G.V. Nikolaev.
Yeah, this isn't your standard academic publication. Nikolaev, writing from Tomsk in Russia back in 2002, basically argues that physics, especially electromagnetism, is in a kind of deep crisis.
A crisis? That sounds pretty dramatic. What's the core idea?
He argues that if you really look closely at a whole bunch of research, experiments, observations, things that maybe get ignored, they just don't quite fit the standard picture. He thinks the very foundations, the philosophical concepts even, need a serious rethink.
Wow, okay. So our mission today, our deep dive, is to unpack what Nikolaev is claiming in this book. We want to understand his critique of the standard model, explore these unknown secrets he talks about.
We'll look at the evidence he presents, the weird phenomena, and then get into the really controversial stuff, these claims about free energy devices. And we want to be clear, we're exploring his arguments, his interpretations, based solely on this source material.
Exactly. It's like trying on a different pair of conceptual glasses. We're not necessarily saying these glasses show the absolute truth, but we want to understand the view they offer. Prepare yourselves, because this goes into some pretty unconventional places. And hey, while you're preparing, if you find this kind of exploration fascinating, do us a solid, hit that like button, subscribe, and maybe ring the notification bell so you don't miss our next deep dive.
Always appreciated. Okay, so where do we start? Probably with the familiar ground, right? What is the standard picture Nikolaev is critiquing?
Right. Section 1 in the book is a nod to the giants, Faraday and Maxwell. Michael Faraday, mid-19th century, amazing experimentalist. He showed electricity and magnetism weren't separate things. They were interconnected. Electromagnetic induction, right? Changing magnetic fields, creating currents.
And vice versa. His work was revolutionary. Practical stuff came out of it. Generators, motors, the whole second industrial revolution basically got its power source from understanding Faraday's discoveries.
And then James Clerk Maxwell comes along later in the 19th century and does this incredible theoretical synthesis. He takes all the known laws, Faraday's work included, and boils them down into just 4 equations.
Maxwell's equations. Elegant, powerful. They describe how electric and magnetic fields are made by charges and currents, how they interact, and maybe most importantly predicted that these fields could travel through empty space as waves.
Electromagnetic waves traveling at the speed of light, because, as it turned out, light is an electromagnetic wave. That prediction alone was huge.
Absolutely. And for well over a century now, those equations, especially describing fields in a vacuum, have been seen as basically the complete story for classical electromagnetism. They underpin so much radio, relativity, modern electronics.
Okay, so that's the established view. Widely accepted, incredibly successful. But now Nikolaev enters the scene and, as you said, claims there's a paradoxical situation. Where does he see the cracks?
Right. This is where section 2 of the book really lays out the conflict. He argues that despite all that success, the standard model based on Maxwell is fundamentally incomplete. He says there are significant gaps, internal contradictions even, when you look closely or when you consider certain experimental results or phenomena that just get, well, ignored or dismissed.
He uses strong words like deep crisis. What's driving this crisis, according to him? Is it just about electromagnetism?
It seems to start there, but he suggests it points to flaws in the initial philosophical and physical concepts underpinning modern physics more broadly. He claims his analysis of numerous studies shows that almost all the basics need reevaluation. Electromagnetism is just the most obvious starting point.
So he's suggesting that maybe when physics was being formalized, especially around electromagnetism, maybe certain paths were taken, certain assumptions made that inadvertently closed off other possibilities.
That seems to be the implication, that maybe the focus became too narrow, too restrictive, possibly overlooking or excluding phenomena or types of interactions that didn't neatly fit the framework being built at the time. A sort of historical path dependency that led us to an incomplete picture.
Okay, so a critique of the foundations. Let's get into the specifics then. What does Nikolaev argue needs to change? What are these unknown secrets? This seems to be the core of Section 3.
Yeah, this is where he really starts diverging. He argues the existing theories fail to describe all observed phenomena accurately. And he points a finger, quite explicitly actually, at Albert Einstein's influence.
Einstein, how does he fit in?
Nikolaev suggests that Einstein's views on electromagnetism, and particularly the framework of relativity, while revolutionary, actually helped steer physics down a path that reinforced this incomplete understanding. He seems to think that some of the core assumptions tied to relativity might have inadvertently masked or excluded the very phenomena Nikolaev believes are crucial. The crisis, in his view, stems partly from rigidly adhering to those Einstein-era assumptions about space, time, and fields.
Interesting. So what's the specific piece he thinks is missing from Faraday and Maxwell's framework?
The big one, the absolute core of his argument, is the distinction between transverse and longitudinal interactions.
Okay, break that down for us. Transverse.
Think of the standard way we learn about magnetic forces, the Lorentz force, right? A charge moves through a magnetic field, and the force is sideways perpendicular to both the motion and the field lines. Or two parallel wires with current, they push or pull each other sideways, perpendicular to the wires. That's transverse. The effect is perpendicular to the direction of motion or the line connecting the interacting things.
Like ripples spreading out sideways on a pond.
That's a decent analogy, yeah.
Yeah.
Most of conventional electrodynamics, Nikolaev argues, focuses only on these transverse effects. Maxwell's waves propagating through space are transverse waves. The electric and magnetic fields oscillate perpendicular to the direction the wave is traveling.
Okay, so what's longitudinal then?
Longitudinal is the opposite. It's a force or interaction that acts along the line connecting the interacting elements. A direct push or pull parallel to the direction of motion or the connection. Imagine not just sideways ripples, but a direct pulse sent straight down a connecting rod.
Like a sound wave traveling through air, the compression and rarefaction is along the direction of travel.
Exactly like that. Nikolaev argues that conventional physics has almost entirely neglected this possibility for electromagnetism. He even uses diagrams in the book, like figures 1 and 2 he references, to try and visualize this difference, showing conventional forces acting sideways and contrasting it with forces acting directly along the axis or connection line. This neglected longitudinal interaction, he claims, is the fundamental missing piece.
So while we've built technologies based on transverse effects, he's saying there's this whole other mode of electromagnetic interaction, a direct push-pull that we've ignored.
Precisely. And this idea, this missing longitudinal component, leads him to propose something really radical, which he details in Section 4, the concept of a scalar magnetic field.
Scalar magnetic field. Okay, magnetic fields are vectors, right? They have magnitude and direction. North pole, south pole. You can draw field lines. What's a scalar field?
Scalar quantities just have magnitude, no direction, like temperature or pressure. In standard electrodynamics, there's a concept called the magnetic scalar potential, but it's usually treated as just a mathematical tool, especially in certain situations, not a real physical field itself in the same way the vector magnetic field is. Nikolaev argues it is a real physical field.
And where does this scalar field exist, according to him?
He proposes it exists alongside the familiar vector magnetic field, particularly around moving charges or current elements. But crucially, he associates it with the axis of motion, or the line connecting interacting elements. It's intrinsically linked to those longitudinal interactions he talks about. It's not about north-south poles in the same way. It's more about a potential or field strength along that direct line of interaction.
That is fundamentally different. A magnetic field without inherent directionality in the usual sense.
Yes.
And the book claims the scalar field has some really weird properties.
Oh, yeah. Section 4 goes into this.
Yeah.
According to Nikolaev, the scalar magnetic field interacts with matter in ways the standard vector field doesn't. We know the vector field strongly affects ferromagnetic materials like iron, right? That's how magnets work.
Sure.
Nikolaev claims his scalar field interacts differently, not just with magnetic materials, but even with ordinary non-magnetic materials, in ways that conventional theory just cannot predict. He talks about longitudinal forces, direct pushes or pulls along the axis, appearing where they shouldn't, or even causing strange rotational effects or other changes in materials, effects that aren't explained by the Lorentz force or standard magnetic dipole interactions.
So it's not just academic. He's saying this field does things, observable things that are unexpected. Does he cite experiments?
He does. He refers quite a bit to experiments, including his own and those of others, often involving specific setups with coils or magnets. Toroids, those donut-shaped coils or magnets, seem particularly important in his work.
Why toroids?
Well, a perfect toroid theoretically confines its vector magnetic field mostly inside the donut ring. Outside, the standard field is very weak. Nikolaev argues that these configurations, however, can be strong generators or interactors via the scalar magnetic field, which might manifest along the axis passing through the hole of the donut.
Ah, okay. So experiments where you might not expect much force based on the external vector field.
Exactly. He describes experiments referencing work like the Siberian CPOL-II coil of longitudinal interaction and research by people like Stefan Marinov, where specifically arranged toroids or other coil structures reportedly produce significant axial forces, pushes or pulls along their central axis. Forces that are supposedly much stronger or behave differently than anything predicted by standard calculations based on the residual vector fields. He attributes these observed longitudinal forces directly to the scalar magnetic field.
So he's trying to ground this theoretical idea of a scalar field in tangible experimental results, even if they are outside the mainstream.
That's the claim, that these experiments demonstrate the reality of the scalar field and its associated longitudinal forces, phenomena that standard theory fails to account for.
And why is this discovery, if true, so important according to the book? What are the big implications?
Well, if he's right, it means our fundamental understanding of electromagnetism, a cornerstone of physics, is incomplete. We're missing a major piece of the puzzle regarding how charges interact, how fields behave, how energy works. And that means everything built on that foundation might be limited or even slightly flawed.
Which impacts potentially everything.
Potentially. But the most immediate implication he stresses is technological. If this scalar field and longitudinal interactions exist and have these unique properties, but we don't understand or acknowledge them, then we're completely missing out on ways to manipulate them. We might be leaving potentially powerful and novel technologies on the table simply because our current physics doesn't give us the tools to even conceive of them.
Okay, so a major critique, a proposed missing piece, longitudinal interaction and scalar fields, and claims of experimental support. Now, the book seems to suggest these aren't just new ideas, but maybe rediscovered ones. Section 5 is called All Could Be Expected Much Earlier.
Right. He argues that hints of these effects, these longitudinal interactions or scalar field phenomena, were actually present in earlier scientific work, maybe even back in the 19th century, or in observations that were just never properly understood or integrated. They might have been dismissed as experimental errors, anomalies, or just didn't fit the mathematical framework being developed, the vector-based approach that became dominant.
So physics might have taken a turn that inadvertently sidelined these concepts?
That's his historical argument, that the clues were there, but the mainstream path went in a different direction. He then circles back to the more contemporary experiments, Siberian CPOL-II, Marinov's work again, others, as confirmation that these sideline concepts are real and demonstrable now, if you know what to look for and how to set up the experiment specifically to reveal these effects, perhaps by minimizing the standard transverse effects.
And it's not just lab experiments. He connects this to things observed in nature.
Yes, definitely. The book makes the quite broad claim that many unexplained natural phenomena, atmospheric anomalies, strange lights, maybe even geological phenomena, could potentially be understood as manifestations of these unconventional electromagnetic principles, particularly involving scalar fields or longitudinal waves interacting with the environment in ways standard physics doesn't predict.
And this is where it gets really controversial, linking these ideas to UFOs.
Yeah, the book goes there. It explicitly suggests that phenomena often reported as UFOs, unidentified flying objects, or other strange aerial or technological occurrences might not be alien spacecraft in the conventional sense, but perhaps manifestations of advanced technology, maybe even terrestrial, maybe not, manipulating these very scalar fields and longitudinal forces.
How does he make that connection? Based on reported characteristics?
Exactly. The source points to common descriptors in UFO reports: silent operation, incredibly high speeds, non-inertial movements like instant acceleration or right-angle turns, localized atmospheric effects like glowing plasma or electrical interference, effects on nearby electronics or even biological organisms. Nikolaev argues that these characteristics are incredibly difficult, if not impossible, to explain using conventional aerodynamics and electromagnetism based on transverse effects. But maybe, he suggests, if you had a technology that could manipulate strong scalar magnetic fields or generate directed longitudinal forces, you could potentially achieve propulsion and maneuvering characteristics that seem impossible within our current framework. Silent, reactionless drive, interaction with the surrounding medium. These might become plausible if this unknown physics is real.
So he's reframing UFOs not necessarily as extraterrestrial, but as potentially explainable physical phenomena, just operating under a physics we don't fully grasp yet.
That seems to be the perspective presented in the source. It's taking these persistent anomalies seriously and suggesting they might be crucial data points indicating the incompleteness of our current physics. It's a way to potentially bring these phenomena into the realm of physics, albeit an expanded, unconventional physics.
That's a wild thought. And you mentioned biological effects earlier. Section 8 of the source apparently delves into that.
Yes, it touches upon the idea that living systems, being complex electrochemical systems themselves, might be particularly sensitive to or interact strongly with scalar magnetic fields in ways that aren't accounted for by just looking at standard electric or magnetic field effects like heating.
What kind of effects are claimed?
The book mentions observations, again from non-mainstream research often, suggesting potential therapeutic applications, accelerated healing, pain reduction, other physiological responses when biological systems are exposed to fields generated by devices designed to produce scalar magnetic effects according to Nikolaev's principles. The mechanisms aren't fully fleshed out in the source, but the claim is that observable, repeatable, non-thermal biological effects occur, providing another line of evidence for the reality and significance of these fields.
If true, that opens up entirely new avenues for medical technology, but also raises questions about potential hazards.
Precisely. If these fields exist and interact with life, understanding them becomes crucial for both potential benefits and risks. From Nikolaev's viewpoint, ignoring them means we're flying blind in potentially important areas of bioelectromagnetics.
Okay, this naturally leads us to the topic that always generates buzz in these discussions, free energy. Section 7 is dedicated to this. How does Nikolaev's book define or approach this term? It's often associated with, well, perpetual motion machines.
Right, and the book is careful, not about violating the fundamental law of conservation of energy, creating energy from absolutely nothing. Instead, free energy, in this context, refers to tapping into energy sources that are ubiquitous and vast, but not currently recognized or utilized by our conventional technology.
Such as?
The main candidates mentioned or implied are the zero-point energy, or vacuum energy, the idea from quantum physics that even empty space is seething with fluctuating energy fields, or, perhaps more directly related to his core ideas, harnessing energy from the interactions involving the scalar magnetic field or longitudinal waves themselves. The idea is that conventional methods like a standard generator using Faraday's law of induction, based on changing magnetic flux, a transverse effect, only capture a fraction of the total electromagnetic energy potentially available.
So it's about finding a loophole or a backdoor based on this expanded understanding of electromagnetism to access energy that's already there in the environment or the vacuum, but invisible to our current tools.
That's the concept presented. It's not breaking conservation laws, but finding new ways to interact with the universe's energy budget, ways that become possible if Nikolaev's physics, with its scalar fields and longitudinal interactions, is correct. Manipulating these might allow for extracting energy from the vacuum or environment without a proportional conventional energy input being consumed in the process.
But the book goes further, right? It claims there are actual devices that do this. Section 7 seems to list quite a few.
It does. This is where Nikolaev presents what he considers concrete examples of free energy or overunity, output greater than measured input devices.
So who does he mention? The Testatica machine often comes up.
Yes, the Testatica, associated with Paul Baumann and the Meiternithic community in Switzerland. The source describes it as a device claimed to have run for over 15 years, producing significant electrical power, apparently without any conventional fuel or input, drawing energy from an unconventional source. Nikolaev references reports describing it, sometimes calling it a perpetuum mobile, and notes the community's secrecy around its exact workings, which obviously hinders independent study but fuels the mystique. Its reported long-term operation is presented as evidence supporting the underlying principles.
Okay, what else? Potapov's thermogenerator.
YU Potapov's device. According to Nikolaev's source, this is based on the Rankine effect, which involves temperature separation in a vortex tube. Potapov allegedly adapted this, using swirling fluids, like water, to create a device that outputs significantly more thermal energy than the electrical energy needed to run the pump. The claim presented is that it achieves over 100% efficiency by extracting cold energy from the vacuum or the ambient environment, essentially acting like a heat pump pulling energy from an unrecognized source.
Fascinating. Using fluid dynamics potentially linked to these energy concepts, and Stefan Marinov, whom you mentioned regarding experiments.
Marinov is discussed again here for his claim generators. Nikolaev highlights Marinov's work with devices like the Siberian coil, which were supposedly based on manipulating longitudinal electromagnetic effects. The source presents Marinov's claims of demonstrating anomalous energy production and achieving overunity efficiency in his experiments, viewing them as strong validation for the potential of harnessing these unconventional interactions for power generation.
The list goes on in the book, doesn't it? Floyd, Sweet, Hubbard, Nikolaev himself.
Yes, there's a survey. Floyd Sweet's vacuum triode amplifier, VTA, is mentioned. A solid-state device claimed to produce kilowatts of output from milliwatts of input, supposedly by conditioning magnets and tapping vacuum energy. The Hubbard generator is referenced as another early example, using specific coil and magnetic configurations, and Nikolaev includes descriptions of his own generator designs, which he claims experimentally demonstrate the principles outlined in his book, harnessing scalar fields and longitudinal forces to produce excess energy or anomalous effects.
So for each of these, the pattern is, here's the inventor, here's the unconventional principle claimed, often involving magnets, special coils, scalar longitudinal effects, vacuum energy, and here's the reported result, energy out seemingly exceeding energy in, defying conventional explanation.
That's the structure, yes. The book presents these as a collection of empirical data points supporting the core thesis that there's more to electromagnetism than we think, and that this more has practical energy implications.
Looking at these descriptions in the source, are there common threads? You mentioned magnets and coils.
Definitely. The frequent use of permanent magnets in specific, often complex or counterintuitive arrangements seems key. Specific coil geometries, toroids, bipolar windings, caduceus coils, things designed perhaps to cancel conventional fields, while enhancing these other purported effects are often mentioned. And underlying all of them is the claim that they operate based on these unknown secrets. Scalar fields, longitudinal waves, direct vacuum interaction rather than just standard induction. And the result is always presented as anomalous energy gain or efficiency far exceeding 100% by conventional metrics.
It paints a compelling picture if you accept the premise and the reported results, but it leads back to that crucial question. If any of this is real, why isn't it mainstream? Why are these unknown secrets?
Nikolaev addresses this directly. His perspective, woven throughout the book, points to resistance from the established scientific community. He suggests a combination of factors. Intellectual inertia. It's hard to overthrow established paradigms, difficulty in getting funding or publication for truly radical ideas, potential active suppression by vested interests in current energy systems, and fundamentally, the lack of a widely accepted theoretical framework within mainstream physics to even make sense of these claims.
So, because the phenomena don't fit the current map, they're either ignored, dismissed as errors, or, if they persist, seen as fringe.
That's the essence of his argument. He believes these devices and concepts remain unknown secrets because accepting them would require that fundamental reevaluation of physics he calls for, particularly rebuilding electrodynamics to include scalar fields and longitudinal forces. Without that theoretical shift, these results will always look like anomalies or impossibilities from the perspective of the current paradigm.
Okay, let's try to pull this all together. Sections 6 and 9 of the source seem to aim for a grand synthesis. Section 9 is titled, At Last Electrodynamics Becomes Complete. What's the big picture Nikolaev is painting?
He's trying to connect all the pieces. The critique of Maxwell and Einstein's legacy, the proposal of longitudinal forces and scalar fields, the experimental evidence, the explanation for natural anomalies in UFOs, and the potential for free energy. He argues that all these seemingly disparate elements actually fit together coherently within a revised, expanded framework of electrodynamics.
And that Section 5 title, All Could Be Expected Much Earlier, really emphasizes his view that this isn't totally out of the blue, but a return to or recognition of things missed.
Exactly. He argues that the potential for this more complete understanding was latent in physics for a long time, hinted at by various observations and theoretical possibilities, but the mainstream development path simply didn't incorporate them. It's a narrative of missed opportunities, of physics taking a potentially less fruitful turn decades ago.
So the ultimate goal, the vision in Section 9, is to finally achieve a complete theory of electrodynamics.
Yes. By adding back the missing pieces, the longitudinal interaction, the physical reality of the scalar magnetic field, Nikolaev claims electrodynamics transforms from an incomplete, somewhat paradoxical theory into a truly comprehensive one. One that can naturally explain everything from standard phenomena to the anomalies, and crucially, points the way towards harnessing new energy sources. He even hints this more complete electrodynamics might be a stepping stone towards unifying physics further.
It's more than just fixing equations. It's presented as a fundamental reopening and reconstruction of a core area of physics, a call to action, really.
Absolutely. The book ends with a powerful plea for scientists to fundamentally reevaluate the foundations, to question assumptions, to look again at experiments dismissed as anomalous, to be willing to reconstruct theories based on all the evidence, not just the evidence that fits the current comfortable picture. It's a call to overcome that inertia he described and embrace the possibility that our understanding needs a major overhaul.
It really challenges the scientific community to consider if clinging too tightly to the established framework might be blinding them to deeper truths.
And to see those anomalies, those unknown secrets, not as annoyances, but as potentially crucial signposts pointing towards that deeper reality. A reality, he argues, that holds the key to future progress in both fundamental understanding and transformative technologies like energy.
Okay, so let's quickly recap this journey through Nikolaev's unknown secrets. We started with his critique. Conventional electromagnetism, despite its successes, is incomplete because it misses longitudinal forces and the crucial scalar magnetic field.
Right. Then we saw how he uses claimed experimental results, like those with toroids or from researchers like Marinoff, plus observations of natural anomalies and even UFO phenomena, as evidence supporting these missing concepts.
And this leads to the potential for free energy, not magic, but tapping unconventional sources like vacuum energy or scalar field interactions, with devices like Testatica, Potapov's, Sweet's VTA cited as alleged examples in the source.
It all builds towards his vision of a completed electrodynamics, a fundamentally revised physics that can explain more and potentially unlock revolutionary technologies, urging science to overcome resistance and embrace this new paradigm.
It's undeniably a challenging perspective, pushing right up against the boundaries of accepted science. It really makes you stop and ask, what if? What if the physics we rely on is missing something fundamental?
Well, what if some of these persistent anomalies aren't just noise, but signals of a richer, more complex electromagnetic reality than we currently model?
The implications, if any of this were proven true, are just staggering.
Yeah.
For understanding the universe, for technology, especially energy.
It would change everything.
So here's a final thought to leave you with, drawn purely from the perspective presented in Nikolaev's book. What if the next great breakthroughs don't come from pushing the current frontiers further, but from looking back, questioning the very foundations we thought were solid, and daring to investigate phenomena and forces like scalar fields and longitudinal interactions that have been relegated to the fringes? If these unknown secrets hold even a fraction of the potential Nikolaev claims, what kind of future might that unlock?
Definitely food for thought. A reminder that sometimes the biggest secrets might be hidden in plain sight, just waiting for us to adjust our perspective.
Indeed. Thanks for joining us on this very deep, very unconventional dive today.